Hot solution of barium nitrate from an evaporator contains 30.6 kilograms of barium nitrate per 100 kilograms of water and goes to a crystallizer, where the solution is cooled and barium nitrate crystallizes out. On cooling, 10% of the original water present evaporates. So for a feed solution of 100 kilograms total, calculate the following. The yield of crystals in the solution is cooled to 290 Kelvin or 17 degrees Celsius, where the solubility is 8.6 barium nitrate per 100 kilograms of water, and the yield if cooled instead to 283, all right, where the solubility is 7 barium nitrate per 100 kilograms of water. So let's try. What is the given? You're given the conditions on top. So let's draw those. So you're basically given the crystallizer in here. And then you have the feed, Z. And then in here, let's separate this as the mother liquor and the crystal. So what else are given? Contains 36 kilograms of barium nitrate. So hot solution and goes to a crystallizer where the solution is cooled. On cooling, 10% of the original water present evaporates. So I can say here that the vapor is 10% of the water from the feed. 10% of the original water present evaporates. So that means this one is water from the feed, right? And then what I have is that the solubility of the entering solution is 30.6. So I have 30.6 kilograms of barium nitrate per 100 kilograms of water, right? Of us. Yield of crystals in the solution at 17 Celsius and yield is cooled to 283 Kelvin. So your required yield of crystals, temperature is 17 degrees Celsius. And then B, yield at 283 crystals. Temperature is 283 Kelvin. So how do we solve this? So let's go to the solution. First is, of course, our overall material balances. For the OMB, we know that feed is equal to V plus L plus C. We know that the feed is 100. And then everything else we have to solve for. Okay. So for the solubility, let's go to this first. Because the solubility will give us the how much is being dissolved as it enters the crystallizer. So its F is 30.6 all over 100 plus 30.6. Can you please give this to me? Can you please calculate this for me? 0.2343. Now, look, the feed only contains X of the feed and then the remaining is water. So can I safely say that X of the water is 1 minus X of the feed? Because it's purely just barium nitrate and water. There are no other hydrated crystals. So what is X of the water, please? 0.7657. Therefore, I can say that the V there is basically 0.1 XW of the feed plus L plus C, and then this one would give us 0.10 XW is 0.7657 times F, which is 100, plus L plus C. Can you please solve this for me? This is 100. This is 7.657 plus L plus C. What will this give me? What is 100 minus this? So 92.343 is equal to L plus C. So let's go to the required. So letter A, barium nitrate balance. This is at temperature is 17 degrees Celsius because that's for letter A. So this one is F, X of F is equal to C, X of C plus L, X of L. So you know that the F is 100 and then this one is 0.2343. The thing is the crystal. What's the crystal here? Is it anhydrous or hydrous or hydrated? If it's anhydrous, that means I can say that Xc is equal to 1. So here, note that if it's anhydrous, Xc is 1.0. So I can say here that this is simply C times 1.0. Plus, the thing is we don't know the L, but we can get XL. How? Because XL in here, in order to solve for XL, diba? How do we solve for XL, guys? Isn't it that they are actually based on the solubilities and then the solubilities are given? So for the solubilities, I can say that that's 8.6 at 17 degrees. So this one, it's basically 8.6 kilograms of barium nitrate for every 100 kilograms of water, right? So that's 108.6 kilograms of solution. And then the bottom, so that we won't need to solve later on, this one is 7.0. So I can say that at the bottom, that is 7.0 kilograms of barium nitrate for every 107 kilograms of solution. So can you please give me the answers in here? The first one, can you please give me 0.0792? 0.0792. What about the second one, please? 0.0654. Thank you. Right. And guys, by the way, do take note that the temperature at the crystallizer, because it says here, if you were to cool them, so initially, you don't know what temperature it is at, but all you know is the feed is at this composition. But what happens is that as it exits the crystallizer, the temperature of your magma would be the same as the temperature of your mother liquor and your crystals. If there's no other cooling effects after that, right? That's one of our assumptions that this one, let's just say this is M, that in here, the temperature is M, is the temperature of the L, is the temperature of the crystals as well. So that means you have those two XLs Here we can already solve L times XL at 17 degrees, 0.0792. All right. So that means here you can already solve because remember earlier we were able to get one equation. This one is our first equation. Let's call this equation one. So equation one is 92.343 is equal to L plus C. And then you have our second equation in here. Let's just call this equation A. So that means equation 1 and equation A. Can you please solve for L and C for me? What's L? What's C? C is 17.50. Very good. What about the L, please? 74.84. So what's being asked in here? Yield of crystals, 17. So the crystals. Therefore, I can say here that the yield is 17.50 kilograms of barium nitrate crystals for every 100 kilograms of feed solution. So this is your answer for number one, letter A. So let's go to letter B. Barium nitrate balance. Temperature is 283 Kelvin or 10 degrees Celsius. So let's do this. FXF, so 100 times XF does not change, 0.2343. CXC, since it's anhydrous again, that is 1.0. LXL, so the XL, 10 degrees Celsius is 0.0654. There. So, and then equation 1. So again, let's call this equation B. So using equation 1 and B, what's the answer, guys? Your L and C. So your L is 73.7353. Your C is 18.6077. Therefore, the yield at that point is 18.61 kilograms of barium nitrate, 100 kilograms of feed solution. So this one is your letter B. So this one is quite easy to you because this one's basically just a recall of your pickout, your stoichiometry. It's quite easy, right? Given the crystallizer, the unit, so it would be essential to draw the process flow diagram first and then put all the givens that you are provided, and then whatever other data that you are provided or you might need either can be found in the handbook or in your formula sheets, or I might be providing them. And then some of the necessary things that you have to think of is that first, if it's anhydrous, take note that Xc will be equal to 1. If it's not anhydrous or if it is hydrated, you have to solve for the Xc first.